Okay, so I've got some new stuff for you this week. The last video was all review. Hopefully you have a good vision of atoms. And now we're going to start to talk about stuff that's a little more complicated. I'm going to break it down so you can understand it. You can all understand this stuff. And so we're going to talk about different kinds of atoms. Okay, there are 92 different kinds of atoms that occur in nature. And they all have their own specific characteristics, and both as the structure of the atom and also the way they behave. And the way they behave is completely determined by their structure. So what do we know? We know that every atom has protons in the nucleus in the middle. And they have a specific number of protons. And number one is hydrogen, because every hydrogen nucleus has one proton in it. And number 11 is sodium, because every sodium atom has 11 protons in it. And calcium is 12, and chlorine is 17. And you don't need to remember that. I will give you one of these. It's called a periodic table, and it tells you, lithium is number 3, beryllium is number 4, potassium is 19, calcium is 20, chlorine is 17, fluorine is 9. Okay, you don't need to remember that. You can always look that up. And so what we need to think about is the protons in the middle. The more of them there are, the more the positive attractive force in the nucleus. And the more electrons there are, and what I forgot to tell you right there is that the number of protons in an atom is exactly the same as the number of electrons. So if chlorine has 17 protons, it also has 17 electrons. If fluorine has 9 protons, it also has 9 electrons. Okay, so for every atom, there are positive charges and negative charges, and they're the same. And that means an atom itself has no charge, because the number of positives equals the number of negatives, and they balance out. Okay, that's where the interesting part of chemistry is going to happen. So let's get back to the idea that protons and the nucleus attract electrons, because some atoms pull on electrons harder than others, and we're going to call those the electron bullies. So there are two things that allow an atom to pull on an electron with more force. And one is if the protons are closer to the electrons, right? So smaller atoms pull harder on the electrons because they're closer. It's sort of like gravity, right? If you get further from the Earth, the force of gravity gets weaker. If you get further from the nucleus and you're an electron, the force of the electromagnetic force gets weaker. So what makes the pull toward the nucleus stronger? One is if there are more protons, more positive charge, more pull, and two is if the electrons are closer. So, okay, where do we go from here? So some atoms are Wimps. They don't pull on their electrons hard because for the number of protons, they're big. And so on the periodic table, we call those metals. Metals don't pull hard on their electrons. And so these are all the Wimps over here, okay? Because they tend, for the number of protons, they tend to be big, right? So their protons, the positive force, if they're big, the electrons are further away and they can't pull on them as hard. Okay, and so those are metals. Those are the Wimps. The others pull the bullies. So we have the Wimps who don't pull on their electrons hard, and then we have the bullies. And those are the badass atoms like fluorine and chlorine and bromine. Okay, those are the ones over here. You don't need to remember any of this. It just needs to make sense to you that if there are a lot of protons in the middle and the electrons are close, they're going to pull on them really hard. Okay, so there are bullies and wimps, and so here's where it gets interesting, because the bullies can steal electrons from the wimps. Okay? These badass atoms can take electrons right away from the wimps. For example, okay, I talk about chlorine a lot. I like chlorine and fluorine. We're going to talk about chlorine because that's one of the bullies, and it's one you've all heard of. And one of the wimps, a metal, is sodium. So sodium is a wimp, chlorine is a bully, and chlorine will steal an electron right away from sodium. Bang, got it. What does that do to the charge of chlorine? It used to have the 17 protons and 17 electrons, but now it's got more electrons, so it has a negative charge. The sodium used to be balanced, but it's lost a negative charge, so now it has more positives than negatives and has a positive charge. And what happens? The positive sodium and the now negative chlorine attract each other, and they're held together, and that's what we call salt. Okay, so chlorine is a nasty yellow, highly reactive gas, poisonous. Sodium is a scary metal that is incredibly unstable. But when they have a chemical reaction, we get salt. Okay. So what should you have gotten out of this? That some kinds of atoms pull on their electrons harder than other kinds of atoms. And the things that make them do that, they have more protons in the middle for their size. Okay, so they have more ability to pull. The ones that are wimps, for their size, they don't have as many protons. Okay. I will get you a copy of the periodic table. I always like to have them be on gold paper. I don't think it'll scan that well in gold. It doesn't stand out that much, so I might have to give you a white one. Sorry about that. All right, what else do I want to say? Listen, I hope that this is easier for you than for me. The principals are getting the message that this is really, that the school is hard for you guys and stressful. And I want you to know I'm committed to trying to do things that make sense. I don't want to give up on teaching you science. I want to try to explain things and show you things in a way that makes sense. But if there's something I can do for you, please reach out. Don't forget, I have office hours. I'll try to get, do the best I can. And I hope you do that too. Okay. Hang in there.